So just to recall the sine rule is A over sine of angle A is equal to B over sine of angle B, which is equal to C over sine of angle C. And that applies to a non-right angle triangle. Of course, if we had a right angle triangle, we would just use our regular trigonometric ratios, sine, cos, and tan, using SOHCAHTOA to remind us. And you use trigonometry in right angle triangles to find the unknown side or the unknown angle, right? In non-right angle triangles, you can use the sine rule to find missing sides and missing angles. So when I say A over sine A, it means if this side is A, usually the side is represented by the common letter. So if this is side A, then angle A would be here. And then let's say here is side B, then angle B would be here. And then side C is here, so angle C will be there, right? I know I labeled this in a very odd way. You get the point. Side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And we use the sine rule in two instances. Either when you have two angles, so you can use the sine rule when you have two angles and any side to find a third side, right? Or you can use the sine rule when you have um, two sides and any angle. Right? So those are the two instances when you have two angles on any side and you need to find another side, or when you have two sides on any angle. That's when we use the sine rule. And just to like do a quick example, just to refresh our memories a little bit, let's say I have a triangle, and I should be drawing these triangles with the rulers, but just give me a little blight today. So A, B, C, that's triangle ABC. And let's say this angle here is 70 degrees. So angle A is 70 degrees and angle B is 48 degrees. And then the side opposite angle A, which is side A, is 8 centimeters. Let's say I have to find um, side B, for instance. Right? So if I have to find side B, that's the side that is opposite angle B, which is 48 degrees. Now, in order to find side B, I have to use a variation of the rule that includes B over sine B. Now, I would use B over sine B A over sine A is equal to B over sine B because in my triangle, I am given angle A and side A, right? And I have angle B and I need to find side B. So using the sine rule, right, that's A over sine of angle A is equal to B over sine of angle B. And I substitute my values in there. A, side A is 8 centimeters, and the sine of angle A would be the sine of 70 degrees. And that is equal to B, which is the side that I'm trying to find, over the sine of angle B. And then I just cross multiply, right? So, Zafira, this is essentially what you're doing in school, this type of algebra, where you have a variable in like the numerator and you need to cross multiply to rearrange the subject to make the unknown the subject of the equation. So I'll say b times the sine of 70 is equal to 8 times um oh, sorry. I just realized I didn't put in sine um 48 because 48 is B, angle B. Yeah. And that would be equal to 8 times sine of 48 degrees. So if b times sine of 70 is equal to 8 times sine of 48, then b would be equal to 8 sine 48 divided by sine of 70. We just do that on our calculators. Make sure your calculator is in the degree mode. If your calculator is in the radians mode, you're going to get a different answer. So you type it in exactly as is, 8 sine 48 divided by sine of 70, and you'll get 6.33 to 2 decimal places. And that's how you use the sine rule to find an unknown side. Right? Similarly, you can use the sine rule to find an unknown angle when you have two sides and any angle. Let's look at an example like that. So say I have the triangle uh, PQR, and this side R, sorry, this angle R is 60 degrees. Side R is 10, and side QR, or side P actually, is 8. And say I want to find the angle Q. The angle, no, the angle P. Let's say I want to find the angle P, right? So using the sine rule again, we would say side P. Sometimes it's good to label your sides, right? So the side opposite angle P would be side P, so that's 8. The side opposite angle R is 10, so that would be side R. So using the sine rule, side P over the sine of P is equal to R over sine of R. And now we substitute our values in there. So side P is 8. Sine of angle P, well, we want to find out what that is. We don't know what angle P is, and that is equal to R, which is 10 over sine of angle R, which is 60. And now you make P the subject of the formula. So first things first, 10 times the sine P, so you cross multiply, guys. 10 times sine P is equal to 8 times sine of 60. All right, so therefore, sine of angle P is equal to 8 sine 60 divided by 10. And if sine of angle P is equal to that, then angle P is equal to sine inverse of that. So just like with regular trigs, when you're trying to find an angle, you use the inverse function, the inverse trig function. Same thing with the sine rule. So we do sine inverse of 8 sine 60 divided by 10, and you're going to get 43.85 degrees. So angle P is equal to 43.85 degrees, and I took that to 2 decimal places. So that was just to refresh your memory on the sine rule. Okay, the sine rule can be used. This is important, girls, when you use the sine rule. One is when you have two angles on any side to find a given side, sorry, to find an unknown side. And then the second time is when you have two sides on any angle. Now, the sine rule is also given to you in your list of formulae in your exam, right? So don't worry if you can't remember it, but you're definitely going to remember it because you'll use it so much that it's going to end up sticking in your brain. Today, however, we are going to move on to the cosine rule. This is also given to you in your list of formulae, but please write it down while I'm writing it down here so that we can use it. You could have it when we're doing questions. All right. The cosine rule, just like the sine rule, is used to find unknown sides and unknown angles. in non-right angle triangles, the cosine rule is also used to find unknown sides and unknown angles in non-right angle triangles. So if you have, let's say this is A, B, C, right? It still applies. Angle A is opposite side A. Angle B is opposite side B. And angle C is opposite side C. The cosine rule is given as A squared, right? The unknown side or the side that you're trying to find. A squared is equal to squared, so the sum of the squares of the other two sides minus 2 times the product of the other two sides by the cos of the corresponding angle of the side you're trying to find, right? So if I want to find side A, then the cos rule will be A squared. A will have to be the subject. A squared is equal to B squared plus C squared minus 2 times B times C by cos A. And it will be the same thing for B or C, except you'll be interchanging the other sides, right? So if I wanted to find side B, then B squared will be equal to A squared plus C squared, so the sum of the other two sides, minus 2 times the product of the other two sides by the cos of the corresponding angle of the side you're trying to find. So that would be cos of B. And if I wanted to find C, it'll be C squared is equal to A squared plus B squared minus 2 times AB by cos of angle C. So you have to remember that, right? Now, it will be given, so you're just going to write over the letter that I'm trying to find here. This will be given to you in your list of formulae, so you don't have to like try to memorize it, but it would be nice if you do. If you don't worry about it, right? So A squared is equal to B squared plus C squared minus 2BC by cos of A. B squared is equal to A squared plus C squared by cos 2AC cos of B. And finally, C squared is equal to A squared plus B squared minus 2AB by cos of C. Notice I highlighted the fact that if you're trying to find A, we're going to use the rule that starts with A, where A is the subject. And whatever side is the subject, that would be the angle that you're using in the cos of it, right? So just like the sine rule is used in certain circumstances, the cos rule is also used in certain circumstances. First, we're going to look at when you need to find an unknown side. So the first instance when you can use the cos rule is to find an unknown side or missing side given two sides and the included angle. So the included angle would be the angle that is in between the two given sides, right? So to find an unknown side given two sides and the included angle. So unlike the sine rule, it does not need to be the included angle. It could be any angle. For the cosine rule, it has to be the included angle, meaning that if I want to find, let me show you it in an example actually. When you see it in an example, it will make more sense. Right. So let's say I have a triangle. This is my triangle. a non-right angle triangle, so I cannot use the SOHCAHTOA. Let's say this is A, E, C. Let's say this angle here is 120 degrees. And this side is 9 centimeters. This side is 6 centimeters. And I need to find, okay, you know what? Let me make this look a little more believable because that side can't be 6 up there. So 1 second. Even though it's not drawn to scale, I still want it to look a little bit better than how it's looking right now. This is better. Good. So I have this triangle ABC. This side is 9 centimeters, this side is 6 centimeters, and the included angle is 120 degrees. So the included angle, it's called the included angle because it's the angle given between two known sides. Please pay attention to that. Whenever you have two sides and the included angle, and you need to find the unknown side, you can use the cosine rule. Must be the included angle though. So first things first, before I even start to work this question out, I'm going to label my sides, right? So this side is A, this side is C because it's opposite angle C, and this side is B. All right. I need to find the side marked A. So I'm going to use the rule that starts with A squared, right? A hint as well is that if you're finding an unknown side, that unknown side is always going to be opposite the included angle, all right? So using the sine rule here, sorry, the cosine rule, A squared is equal to the sum of the squares of the other two sides. So B squared plus C squared minus 2 times BC cos of A. We're going to substitute our values in there now. So A squared, I don't know what it is. I'm leaving it as A squared. A squared is equal to B squared. B is 6, so that will be 6 squared plus C squared, which is 9 squared, minus 2 times 6 times 9 by cos of the angle A, which is cos of 120 degrees. And now I simplify, right? So that would be A squared is equal to, well, 6 squared plus 9 squared is 117 minus 2 times 6 times 9 times cos of 120. You could type that in exactly as is there, and you'll end up getting minus 54. All right, so then A squared is equal to 117 plus 54, which will give you 171. So A, if A squared is 171, A will be the square root of 171, which will give me 13.08. 13.08 centimeters, and this is taken to 2 decimal places. All right, I'm going to go through it again with you. So I need to find the missing side A in this triangle ABC. I know that I can use the cosine rule because the side that I am trying to find is opposite the included angle and two known sides. Once you have two known sides and the included angle, you can use the cosine rule. So I use the cosine rule. The side that I'm trying to find will be the subject. In this case, it actually is A. So it'll be A squared equal B squared plus C squared minus 2BC by cos A. So therefore, A squared, the unknown side, the square of the unknown side, is equal to the sum of the squares of the two given sides. So that's 6 squared plus 9 squared minus 2 times the product of those. So 2 times 6 times 9 by cos of 120 degrees, because that's the included angle. Guys, you could actually type in this exact same thing, right? This same line, 6 squared plus 9 squared minus 2 by 6 by 9 by cos of 120 directly into your calculator, right? I just did it piece by piece so that you'll see each step, right? But I'm going to type it in directly in my calculator, and I hope you have your calculators with you. 6 squared plus 9 squared minus 2 by 6 by 9 cos of 120. And I got 171, right? And then I just press square root and I get the answer. So you can do that as well. But I just recommend writing out like a couple other steps just in case, you get a little marks for your weekend. Okay? So this is how you use the cosine rule to find an unknown side given sides and the included angle. The next situation, when you use the cosine rule, is to find an unknown angle, right? In order to use the cosine rule to find an unknown angle, right? So this is the second case. To find an unknown angle, I want you all to pay very close attention to this because students make mistakes with this particular solution, the step, sorry, in this case a lot more than in the sine rule, right? So to find an unknown angle when all three sides are given, right? So let's see how that works. Draw my triangle. So again, a non-right angle triangle, even though this looking a little right angle-y, it's non-right angle. Gonna make it a little different. Good. Right. So consider this triangle um A, B, C. Let's say this side here is 6 centimeters. This side is 7 centimeters, and this side is 10 centimeters. All right. So calculate angle B. Find angle B. Now, you would not be able to use the sine rule in this case because to use the sine rule, you have to have at least an angle, right? But here, all you have is all three sides. So if I want to find angle B, I would need to use the rule the where side B is the subject. Because remember, you have three, right? You have when A is the subject, when B is the subject, and when C is the subject. So you'll have to use when B is the subject because I'm looking for angle B. So first things first, it's just a nice practice to label your sides. So this side here is B, this side is A, and then C is here. So using the cosine rule, when B is the subject, it would be B squared is equal to A squared plus C squared minus 2 times AC by cos of angle B. And I'm gonna have to rearrange this formula to make cos of the subject. Okay, so let's go. Substituting our values in there. B squared, well, side B is 10. So this will be 10 squared is equal to A squared, which is 7 squared, plus C squared, which is 6 minus 2 times A, that's 7, by C, that's 6, by the cos of angle B, which is what I'm trying to find. Right? Stop simplifying this. This would be 100 is equal to 49 plus 36 minus 2 times 7 times 6. That's 84 by cos of B. Now, Here is the part that students confuse all the time, right? Even I confused it when I was learning it the first time. You see this here? This 49 plus 36 minus 84 cos B. This 84 cos B is a whole term by itself, right? You cannot minus the 84 from it. It's as though you had, consider it as though you had 49 plus 36 minus 84x. You wouldn't take away this 84, right? Because it's the coefficient of x. It means 84 times x. So when you are simplifying this part of the solution, this part of the question, you cannot minus 84 from this. 84 is not a constant. It is part of cos of b. It literally means 84 times cos of b. Okay, and I want you all to, like when you're writing this down, if you're writing it down right now, please put an asterisk there to make sure and write a box around it to make sure you do not minus 84 from the rest of this question. That is incorrect. All right, so simplifying again, this will still be 100 equals 49 plus 36, which is 85, minus 84 cos of B. All right, so then I'm going to move 85 to the other side. So this will be 100, because remember I'm making cos of B the subject. So 85, 100 minus 85 is equal to negative 84 cos of B. And therefore 100 take away 85 is 15. 15 is equal to minus 84 cos of B. And then, just like with regular algebra, you'll have to divide throughout by this minus 84 to get cos of B by itself. So this will be minus 15 over 84 is equal to cos of B. And like with any, when you're finding the angle, you always use the inverse function, right? So therefore, E would be equal to cos inverse of 15 over, sorry, negative 15 over 84. And you could have worked that out to get like the actual decimal if you wish. So cos inverse of negative 15 over 84, which will give me, on your calculators, cos inverse, second function, cos inverse of negative 15 over 84, you're going to get 100.29 degrees to 2 decimal places, right? So,
Excuse me, miss.
Slav,
You could do this one over, please.
for sure, absolutely. We have to do lots like these. So I'm going to do one like it, right? Same thing where we have to find the angle because it's the same steps anyway. But again, guys, you see this part here? We need to be careful with this part here, right? Not to minus this 84 from the rest of it. So let's do another one. All right. Consider, going to be good and use the ruler to draw the triangles. A, E, both. So we're looking at this triangle now. This is angle A, this is angle C, and this is angle B. This side is 7 centimeters, this side is 5 centimeters, and this side is 9 centimeters. And I need to find angle E, right? So because I need to find angle A, I would need to use the cosine rule that has A, side A as the subject of the formula. So this is side A here, it's opposite angle A. Side B would be 7 centimeters. That's opposite angle B. And then side C is 9 centimeters. It is opposite angle C. All right. So I'm using the cosine rule that has A as the subject because I need to find angle A. So let's go. That's going to be A squared is equal to B squared plus C squared minus 2 times B by C, 2 times BC cos of angle E. Again, the reason I'm using this variation is because I want to find angle A. So I'm going to, when I substitute these values into the formula, I'm going to rearrange the formula, simplify first, and rearrange it to make A the subject. All right, so let's go. We're going to substitute our values. A squared is, Jenny, what's A? Which side is A?
5 centimeters.
Right. So A squared will be 5 squared, and then B squared plus C squared will be what? B is what?
7.
Right. So that'll be 7 squared plus C squared. So plus what?
9 squared.
9 squared minus 2BC would mean minus 2 times B. I'm using brackets to represent my multiplication. So 2 brackets B, which is 7, C, so I'm putting C, 9 in brackets as well, cos of A, since I don't know what angle A is. All right, and now I'm going to simplify. So 5 squared is 25, 7 squared is 49, 9 squared is 81, 2 times 7 times 9 is 126 cos of A. I'm going to draw a block around that just so that I know that I cannot actually work that part out. Could only simplify the rest of this. Right? So simplifying again, this would mean 25 is equal to 49 plus 81. That's 130 minus 126 cos of A. Put in the block around it again just to remind myself that I cannot do anything to that as yet. Right? That minus 126 cos A is a whole term by itself. It's like if it was minus 126x, right? So now gonna move 130 to the other side. So this is positive 130. So if I move it to the other side, I will minus it. So that will be 25 take away 130 is equal to negative 126 cos of A. 25 take away 130 is minus 105. So minus 105 is equal to minus 126 cos of A. Therefore, cos of A is equal to minus 105 over minus 126, which will become positive, right? So A would be equal to cos inverse of 105 over 126. So on your calculator, second function, cos 105 divided by 126. Let's see, cos inverse of 105, oops, I wrote the wrong thing, 105 over 126. That will be 33.56. I took it to 2 decimal places, right? So let's go through it again. I need to find angle A. So I have to use the rule, the variation of the rule that starts with that where A is the subject, right? So it will be A squared is equal to B squared plus C squared minus 2BC cos of A. So I substitute my values in there. A is 5, so A squared is 5 squared. B is 7, that means B squared will be 7 squared. And C squared is, sorry, C is 9, so C squared is 9 squared. So 5 squared equals 7 squared plus 9 squared minus 2 times B, which is 7, by C, which is 9, by cos of A. And now I start to simplify. So 5 squared is 25, 7 squared is 49, 9 squared is 81, minus 2 times 7 by 9, which is 126, cos of A. The reason I put this square, sorry, this rectangle around it is so that I know that I cannot touch that as yet. I do not minus 126 from the 49 plus 81. That is incorrect because minus 126 cos of A is one term. It means minus 126 times cos of A, just like if you would have had a normal variable with a coefficient. So consider minus 126 being the coefficient of cos of A, right? So everything else I could work out because they're all constants. 25 is equal to 49 plus 81. So that would be 25 is equal to 130 minus 126 cos of A. So therefore, 25 take away 130 would be minus 126 cos of A, which is minus 105 being equal to minus 126 cos of A. And if that's the case, then cos of A is equal to minus 105 over minus 126. A negative by a negative is a positive. So A is equal to cos inverse of 105 over 126. And then you just type that in directly on your calculator and you will get your answer. Now, since we're here, let's work out for angle B, right? Now, if I want to find, oh no, actually, let's work out for angle C. I want you to try it though, using the same, I'm leaving this on the screen, and I'll tell you, I'll give you a little hint, or a head start, I should say. If we want to find angle C, it means that I need to use the formula in which C is the subject. So that would mean I need to use C squared is equal to A squared plus b squared minus 2 times AB cos of angle C, right? So I want you all to try it for me. Try to find angle C. Send me your work and I want to see everybody's work and send it to me on WhatsApp. So if we need to find angle C, it means that we need to use the version of the rule that starts with C as the subject. So that'll be C squared is equal to A squared plus B squared minus 2AB cos C. So that would be C squared, so that's 9 squared equals A squared. A is 5 squared plus B squared, that's 7 squared minus 2 times 5 times 7 because of angle C. All right, so this is 81 is equal to 5 squared is 25 plus 49 minus 2 times 5 times 7, which is 70 because of C. So that would be 81 is equal to 25 plus 49, 74 minus 70 cos of C. So then 81 take away 74. 81 take away 74 is 7. So that will be 7 is equal to minus 70 cos of C. So then cos of C is equal to 7 over negative 70. Therefore, C is equal to cos inverse. So I think all of you who sent it, well, cos inverse of minus 7 over 70, got all these steps. I really appreciated how you all wrote out your steps. Very, very good. For these types of questions, it's important that you write out your steps clearly and consistently, right? So, cos inverse of -7/70 should be 95.74 degrees. And this is taken to two decimal places, right? So, I was very pleased, guys, with what I saw from you guys just now. Very, very pleased. Good job with your solutions. This one, like the cosine rule, the finding the unknown side is much easier steps to follow than finding the unknown angle. And that's why I wanted to do a little more um, than one example with that one. So I didn't ask you all to do any with finding the unknown side. So let's go back to that. Did you all have it written down? By the way, finding the unknown side. Did you all write down the solution for that one? Because I want you all to try that one for me. I'm gonna give you one where you have to find the unknown side, right? It's the same steps basically, but instead you don't really have to, it's less working for sure. Because like in this one, actually, let's do one just to refresh your memory, and then I'll ask you to do one for me. Right. So let's say we have used being a good person, good teacher, and using my lines to draw shape. Good. So consider this triangle A, A, C, which angle A is 42 degrees. Uh, Side A would be here. And this side is 8 centimeters. This side is also 8 centimeters. So it's an isosceles triangle. All right. Using the cosine rule to find side A, because we need to find A, we'll have to use the rule that starts with A as a subject. So that would be A squared is equal to B squared plus C squared minus 2BC cos of angle A. And now we simply substitute our values into the formula. So A squared is the side we don't know, so that's just going to remain as A squared. B is 8 and C is 8, so this will be 8 squared plus 8 squared minus 2 times 8 times 8 times cos of 42 degrees. So this would be A squared is equal to, guys, you could type this exact thing out in your calculator. I'm just going to do it though. Squared is 64 plus 64 minus 2 times 64. So that would be um 2 times 8 is 128. So minus 128 by cos of 42. So therefore, A squared, let's put all of this in now. So that's 64 plus 64 minus 128 cos of 42. That's 32.8 to two decimal places. So then A will be the square root of that. That means A is equal to 5.73. Took this to two decimal places. All right, so that's how you use the cosine rule to find a missing side. Okay, so I want you all to try one for me. I'm leaving this here. I want you to write out your solution exactly as is. Right, girls. So you're gonna try this one for me. This is triangle AC. I want you to find side A again. Angle A is 110 degrees. Side AB is 9 centimeters and AC is 3 centimeters. So you're finding side A. So we are finding side A. So we're using same squared is equal to B squared plus C squared minus 2BC cos of A. So that would be squared. B squared is, in this case, is 3. So that'll be 3 squared plus C squared, which will be 9 squared minus 2 times B times C cos of 110 degrees. So A squared is equal to 3 squared, that's 9 plus 81 minus 2 times 3 times 9 is 54. So minus 54 cos of 110 degrees. I'm going to type this entire thing into my calculator. So 9 plus, well, 3 squared plus 9 squared minus 2 times 3 times 9 because of 110. I got 108.469. I'm just gonna write that out. I'm leaving that on my calculator. I actually just leave it. I leave the full value and then I press square root. So A would be the square root of that, which is 10.4 or 10.41 if we're taking it to two decimal places. Right? So it's much easier to find a side than it is to find the angle. But honestly, once you do your correct steps, you're going to be fine. Right, girls. So this question is from May, June 2024. So it's recent. Right? The question says, the diagram below shows a quadrilateral PQRS formed by joining two triangles PQS and QRS. Calculate the first part of the question, which is worth 3 marks. Calculate the length of QR. Right? So let's look at the triangle. Now it's two, sorry, let's look at the whole shape. It's two triangles as we can see, right? The question actually tells us two triangles are joined to form the quadrilateral. So QR is this side over here, and it is part of the triangle QRS. So in this triangle, we are given two sides and the included angle. Which rule do you use? Sine or cosine rule to find the length QR? What do you think? Sine or cosine rule?
Sine.
Would you use the sine rule to find the length of a missing side when you have two sides and the included angle?
No, the cosine.
Yeah, you'd use the cosine rule. I mean, you can use the sine rule as well, huh? Because you have, can you use the cosine? No, you cannot use the sine rule there. You have to use the cosine rule, right? So you use the cosine rule when you have two sides and the included angle. So just think of the triangle that I just highlighted, QRS. And I need to find QR, right? If I were to take that triangle out, I could draw it on the side here. right? Or let me draw it in the same orientation so it's not as it doesn't get confusing. So this is S R Q, right? I have this side, this is 25 degrees. This side is 16 meters, and this side is 18 meters. And I need to find RQ. So RQ is really the side S, right? Since it's opposite angle S. And then 18 is R, and Q is 16. So using cosine rule, S, that's the side we're trying to find, is equal to R squared plus Q squared minus 2RQ because of S. All right, so let's see. Squared, S squared is the side we're trying to find. That's QR. So I'm actually gonna write QR instead of S there. So that'll be QR squared is equal to R squared, which is 18. So that's 18 squared plus Q squared, that's 16 squared minus 2 times 18 times 16 by cos of S, which is cos of 25. You'll work it out for me. Well, work it out while I work it out. So this will be QR squared is equal to 18 squared plus 16 squared is 580 minus minus 2 times 18 times 16 is 576 cos of 25. So I'm just going to type the whole thing on my calculator to figure out what QR squared is. So QR squared is 18 squared. I wrote out the steps just for writing it out sake, but I'm literally going to type the first line directly as is in my calculator. So 18 squared plus 16 squared minus 2 by 18 by 16 by cos of 25. And I got 57.9667. And then I take the square root of that. I didn't erase it from my calculator. I left it on the screen and then I just pressed square root to get that QR is equal to 7.61 to 2 decimal places. So 7.61 meters to 2 decimal places. And that's your full 3 marks there.
Excuse me, miss. Excuse me, miss.
Yeah, honey?
Before you did find the square root, can we just all take a moment to appreciate that the answer is 57.9667? Like, it's 6-7, miss.
No, we cannot appreciate it. There's no
Why?
appreciation for it.
Why, miss? It's literally 57.9667.
I'm fed up of hearing 6-7.
Hey, I know Killian and Isabel appreciate it, don't you guys? I know they appreciate it.
Right. So the reason, girls, we couldn't use a sine rule for this is because you would have needed one more angle in order to find the unknown side. Because if we go back, right? If we go back to when we were revising just the sine rule can be used to find an unknown side when you have two angles on any side, or to find an unknown angle when you have two sides on any angle, right? And the cosine rule is used when you need to find an unknown side given two sides and the included angle, or when you need to find an unknown angle given all three sides. So from the time you see something looking like this, sides and the angle in between is given, you know you could use the cosine rule there, right? So in this question here, which was the question from May, June 2024, trig question, well, piece of it at least, you had to find this missing side. And as you can see, this triangle QRS, it's two given sides and the included angle, right? Now you could use the sine rule to find the length ST if you wanted. Let's do that. This is not part of the question, but let's just use the sine rule because we should. We learned how to use it anyway. If I had to use the sine rule to find the side SP, I will be looking at the triangle, this one. I'll be looking at this one here. Triangle SPQ. Right? And again, you can use a sine rule to find an unknown side when you have two angles and a missing side. So I know we did mostly cosine rule today, but let's just, for the fun of it, use the sine rule to find this side, right? So remember the sine rule, it is, um, oops, the sine rule is, in this case, this is SP, which is the side Q, right? Because it's opposite side, it's opposite angle Q. So that would be Q over sine of angle Q is equal to S, side 21, that's S, over sine of angle S. So that would be Q is the unknown side that we're trying to find. That's the side PS over sine of Q, that is 43 degrees. That is equal to S, which is 21 over sine of 72. And now you cross multiply. So PS times sine of 72 is equal to 21 times sine of 43. Therefore, the side PS, which I'm trying to find, will be 21 sine of 43 divided by sine of 72. That is equal to, just type that in on your calculator. Make sure your calculator is in degrees. 21 sine 43 divided by sine of 72. That's 15.06 to 2 decimal places. So just showing you here how you can use the sine rule or the cosine rule to find the unknown side. Given you're given the right circumstances. So you'll use the sine rule to find an unknown side when you have two angles on any side, and you'll use the cosine rule if you have to find an unknown side when given two sides and the included angle. All right, so I am going to send you this note, right? This was just the, you know what? In this part, let me add in one line, right? So here it would be to find unknown side. To find a missing side, fun, two angles on any sides. And then the second situation is if you need to find to find missing angle, so an unknown angle given two sides and any angle. So these are the conditions for the sine rule. And the cosine rule, it's when you have to find an unknown side given two sides and the included angle, that's the angle between those two given sides, or to find an unknown angle given all three sides. You guys were actually excellent today. Good work. I love how you wrote out your solutions. It was easy to follow. And yeah, very proud of you. Very proud of you for today's class, girls. So that would be it for today. And I will